In this video, we're going to talk about fraction equality. So we are still introducing fractions for section 5.1, and they are going to kind of approach fraction equality and all of the ramifications that come out of that. And then we'll look at what it means for fractions to be, or fraction inequality or not equal. Okay, so real quick, I think most of us understand that with fractions, if you compare two fractions like 12 over 24 and 25 over 50, these two fractions do represent the same thing. In other words, 12 out of 24 is exactly half, and same with 25 out of 50. Okay, so we have this idea that they are equal, but to build that up for kind of the concept, like if you want to look at comparing 1/2 to 2/4. Okay, actually here, let me pick a different color just so it doesn't all blend in. Okay, sorry, 1/2 to 2/4. Okay, so here, let's do this. This is 1/2. I'll just use rectangles for ease. And then 2/4, I'll put it right underneath so we can do a hopefully easy comparison. And of course, pretending these are equal. 2/4, somewhere like, okay, so for 1/2, we shade 1 out of the 2. 2/4, we're shading 2 out of the 2. And we're like, oh, look, they're the same. They're exactly equal. And I mean, you can add on as many fractions as you want. Let's do 4 out of 8. We'll keep it easy for comparison. And we're like, okay, cool. 4 out of 8, divide into 8 pieces instead. And shade 4 of them. And the idea is we can easily visualize that these three fractions are equal because the same amount of the whole is shaded, regardless of how many pieces we have broken it into. Okay, now this leads into what's called the fundamental rule. Anytime they say fundamental rule in math or fundamental theorem or something like that, that means it's going to be used a lot. So the fundamental rule for equality of fractions is this: that if one fraction, which we'll call a over b, and another fraction happens to multiply both the denominator and the numerator by a constant, these two fractions are equal. That is the fundamental rule of equality of fractions. And it is used in simplifying fractions. This concept. Okay, so let me give an example. Let's say we want to simplify 6/15. So using the fundamental rule of equality, I would rewrite 6 as 2 times 3, and then rewrite 15 as 5 times 3. And that allows me to see that the constant happens to be 3, which means that 6/15 actually is the same thing as 2/5. And so we can use this to help us simplify fractions. Now, most of us didn't necessarily learn simplifying fractions that way. Most of us use the technique that you can divide top and bottom by a constant. And this is really just a different version of the fraction equality. You could think of dividing by 4 as multiplying by 1/4, but we haven't really talked about multiplying by fractions. So yeah, we could divide 8 over 12, both of those by 4, and simplify to 2/3. Okay, so both of these are ways we do simplifying fractions. Typically, though, if you're trying to really emphasize the fundamental rule of equality, you're going to want to use the first approach that we did on the 6/15. I did want to mention your calculators. If you have a scientific calculator, your calculators can do simplifying of fractions pretty nicely. And I have no problem with you doing that. Most calculators have a fraction button. Again, as long as it's like a straight up scientific calculator. On a lot of the TI calculators, it looks like ABC. It might be capital A, by the way, but it looks like a button that's ABC, something like that. I've seen some calculators that call it N over D, something like that. Sorry, make it more look like a D. Okay. Or I've seen some calculators where they have like what they consider like a box, like a blank, and they're like blank over blank, and the fraction button looks like this. There are different variations of it on the scientific calculator. And the idea is if you want to simplify with a calculator, like if you want to simplify 8 over 12, you would put in 8 and then the fraction button. In this case here, I'll just use the first one, and then 12, and then you need to hit equals or enter or whatever your calculator has. And it'll literally simplify it for you. It's pretty nifty. And if you can't find a fraction button on your calculator, send me a picture over email and I will show you how to do it on your calculator. All right. But yeah, you are welcome to use your calculator to simplify. But if I ask you to simplify a fraction, I want you to show the work. But you can sure use your calculator to make sure. All right. And if you're not being asked to simplify, then you are welcome to do it on the calculator. The other thing they really kind of like to emphasize with equality of fractions is common denominators. All right. And common denominators allows us to kind of start looking at the equality of fractions. So for instance, if you're trying to show the difference between 1/6 and 1/4, that might be kind of hard when you're brand new to fractions. The best way to do that is to start first by visually drawing each fraction. I'll use my rectangles. Excuse me for kind of coughing in the background here or clearing my throat in the background. Okay, so 1/6 is this, and then 1/4 would be this. And you're like, oh, I can kind of tell the 1/4 looks bigger. But what we can do if students have a hard time with that visualization or maybe aren't able to draw such nice pictures, you can create common denominators. In other words, if I take all of the 1/6s or the 6 pieces and divide them in half, and then the 4s, if I divide them into thirds, basically I'm breaking both fractions and thinking of them in terms of 12 pieces as opposed to 4 or 6 pieces. Now it's a little bit more obvious. The 1/6 represents 2/12, and the 1/4 is 3/12. And with that comparison, it starts to be easier to kind of see, oh, okay, 1/4 is definitely bigger, especially if you draw a really nice picture or didn't draw a really nice picture that you could see. Okay, so where did I come up with 12? Well, that's a concept we talked about previously, the lowest common multiple, all right, of 6 and 12. And we had techniques for doing the lowest common multiple. It's been a while. I'm not going to review that. I will maybe do a link to that video. But this is what we're going to use to find what's called the least common denominator. Now, the technique we used previously to find the lowest common multiple, I'm going to introduce another way of doing that really quick. And that's where you actually look at multiples of each denominator. So in this case, we're working with the denominator of 6 and 4. So I'm going to look at multiples of 6. So meaning like 6 times 1, 6 times 2, 6 times 3, and so forth, right? 4 times 1, 4 times 2, 4 times 3. And I'd keep going until I found a number they have in common. And in this case, 12 is what they have in common. So 12 would be the lowest common denominator and also the least common multiple. Okay. So they are, in fact, the same idea. If we want to take our two fractions from our starting moment, we can build them up. Sorry. We can build up the fractions. Wow, there's an E on the. We could build up the fractions using the fundamental rule for equality of fractions. So what I would do is I'd take 1/6 and I'd multiply top and bottom by 2, which gives me 2/12. And then I could take 1/4 and multiply top and bottom by 3, which gives me 3/12. And that, again, allows me comparison without drawing the picture, but instead using the fundamental rule. Awesome. Okay, we're going to talk more about common denominators when we look at adding and subtracting fractions. But I do want to kind of take a moment to kind of throw in another couple ideas that are kind of useful to us. We haven't been really looking at negative fractions, but they will pop up in the homework. So I want to mention there are some rules for the signs of fractions. And that is this. If you have a negative in the denominator, that's exactly the same thing as if the negative was in the numerator, which, by the way, is exactly the same thing as if the negative was written in front of the entire fraction. Saying that we divide by a negative, or we're dividing something that's negative, or the whole thing is negative is all the same thing. Okay, the negative can float. What it is not the same thing as is both of them being negative. Both of them being negative is going to give us a positive, right? Negative divided by a negative is going to give us that positive. Okay, so there we go. Rules for the signs of fractions. And then there's also a nifty test for equality of fractions. And what's nice about this is that rather than simplifying the fractions, we can do some multiplying instead. So it's good practice for multiplication. So it works like this. If AB happens to equal CD, then this is going to occur if and only if AD happens to equal BC. And you might recognize this as a cross multiplication. In other words, if we multiplied A times D and then B times C, those two things, if they're equal, the two fractions are equal. So this is nice if you want to not use calculators, don't want to do the building up method or reducing, but instead practice multiplying. So 42 over 105. Let's see, does it in fact equal 14 over 35? Okay, so grab your calculator and do some multiplying. We're going to multiply 42 times 35. And then we're going to multiply 105 times 14. So if you need to pause the video, grab your calculator. I'm going to tell you what I got. I got 1470 equals 1470. Cool. So there you go. You didn't have to reduce them. We were able just to kind of check real quick with multiplying. Okay, this does kind of lead right into inequality of fractions. So when fractions are not equal, and we kind of have been looking at that, like when we did our comparison of 1/6 and 1/4. And we used the denominators to do that, inequality of fractions. Sorry, there we go. Now there's a couple conceptual thoughts that are useful to kind of understand with inequality of fractions, and that's this. The bigger the denominator, the smaller the fraction. So if I have 1/2, that's bigger than 1/3, which is bigger than 1/4, which is bigger than 1/5, and so forth, right? I could keep writing as many fractions as I want for this conceptual comparison. But it works best when you're using the same numerator for this type of comparison, all right? Also, I can grow the fraction. In other words, 1/2 is going to be, when compared to 3/4, smaller, right? And that's also going to be smaller than 4/5, which is going to be smaller than 5/6. So the idea is that as you increase the numerator and denominator both, that actually ends up giving us a bigger fraction because more parts are shaded, okay? Okay, so real quick, for checking um, inequalities of fractions, to actually check the inequality of fractions. So here, let me actually write that. So to check for inequality, we've already introduced the approach of using LCDs, or least common denominators. So here, let's just do an example really quick. Let's say we want to look at 3/7 and 4/10. We want to see if these two, which one happens to be bigger. All right. Okay, so to do that, I need to find the LCD. Now, I can do the multiples method that we talked about earlier, but I happen to notice that 7 and 10 don't have any numbers in common, meaning like there isn't a number that divides into 7 that also divides into 10 besides 1. Okay. So that would mean that the least common denominator happens to be the multiplication of the two, 7 and 10. So here I'm going to take 3/7 and I'm going to multiply top and bottom by 10, which gives me 30/70. And then I'm going to take 4/10 and I'm going to multiply top and bottom by 7. And that gives me 28/70. And I'm like, aha! So now I can tell 4/10 is bigger. So if I wanted to write an inequality, 4/10 would be the bigger one. Making the alligator mouth face the bigger fraction. All right. Oh, I just realized I wrote an 8 instead of a 70. Sorry about that. 70. All right. So that's one way to do it. Now, you didn't really have to have the LCD to do this. Just a common denominator would work. In other words, if you just multiply them by each other, like the opposite denominator, this would work. The reason we like LCD is it's nicer to work with smaller numbers and it's easier to do in your head rather than grabbing a calculator. We kind of want to try to do as much as we can in our head. It kind of builds that mental dexterity. Okay, and then just like there's a test for equality, there's a test for inequality, which is pretty much equivalent. Wow, that was a very weird U. Hold on. Inequality. There we go. Okay. So if we say AB is smaller than CD, and we cross multiply, right? Here, rather than use the if and only if statement, I'm going to use what's called the equivalent. This means that these two are equivalent statements. This symbol, it's the math symbol for equivalent. Okay. Actually, that should have an E, not an A. I may, yeah, there we go. Equivalent. That is equivalent to saying that AD is smaller than BC if I do my cross multiplication. If it'll let me write. There we go. Or the other direction would be the same as well. In fact, they do state both ways. So let me just take a moment. State both ways is saying that AD is bigger than BC. Great. And let's just test it really quick to feel good about it. Let's compare 3/4 and 7/9. So notice they didn't use 8/9 because 8/9 definitely would have been bigger based on what we talked about earlier. Okay. But let's do the cross multiplying. So let's compare 3 times 9 to 4 times 7. 3 times 9 is going to be 27, and 4 times 7 is 28. So this is bigger, so this is bigger, which means that 7/9 is bigger than 3/4. All right, and then I am going to go ahead and just squeeze into this video the last little topic with fractions because it's really not worthy of a whole video by itself. And that's the idea of mixed numbers and improper fractions. And we will talk more about this when we start doing addition and subtraction in the next section. But it's kind of nice to kind of see it now before we start focusing on math operations. So mixed numbers and improper fractions. So mixed numbers are when we have a combination, combination of whole numbers and fractions. like 3.5. That's a mixed number. Okay. An improper fraction is when the numerator is bigger than the denominator. Wow. Bothered me that the I looked like a capital and it just did not want to let me erase. Numerator is bigger than denominator. All right. Like 5/4. Okay. Now, what's nice is that we kind of built up this foundation of looking at visuals, and those visuals can actually help us convert between improper and mixed numbers. So let me give an example. Let's look at the 3.5. If I wanted to draw out a visual for 3.5, that would mean that I need 3 whole pieces. And then half of another one. So we have all 3 of these, and then half of this one. But here's what's kind of cool. Because we can easily divide all the whole pieces in half, we can instead count how many halves there are. And there would be a total of 1, 2, 3, 4, 5, 6, 7 halves, which happens to be the improper fraction equivalent of 3.5. It works for the 5/4 as well, as you can kind of guess. We basically want to have 1/4 pieces now and 5 of them. Here, I'll kind of do this one still like this vertical. That only has 4, so I need another fraction over here, or another, section of 1/4. So here we go. 1, 2, 3, 4, 5. And now I can see that I have 1 whole and then 1/4 of another one. So that would be the way we can convert between them visually. But there is an actual process for converting, okay? And the process to actually convert is, like, let's say we want to go from improper fraction to a mixed number, 10/3. You literally divide. You do the division of 3 dividing into 10. If it'll let me actually write the division. There we go. Okay, so 3 happens to go into 10 3 times. And that's a 9 with a remainder of 1. Okay, so the number that's up at the top, that's my whole number. And then this is the new numerator. And I'm going to abbreviate numerator. Oh, and I use the number symbol for number. So the whole number here is 3 and then 1, and you'll use the same fraction denominator of thirds. So 3 1/3. That is the mixed number for 10/3. So here, try one real quick just to feel good about it. Let's do, how about 21/8. I'm making this up, so it took me a second to kind of decide, and then I changed my mind. 21/8. There we go. Okay. Do that real quick. Try it, and then maybe pause the video, but I'm going to work it out right now. All right, so 8 goes into 21 2 times, which is 16, and I'll get 5. So the whole number is 2. 5 is the new numerator. 8 is still the denominator. So 2 5/8. All right, to go the other direction, to start with a mixed number and go to an improper fraction, you kind of do the reverse of what we just did. So rather than division, you do multiplication. Okay, we're literally reversing the process of division. All right, so what we do is we take the whole number, we multiply it by the denominator, and then we add the numerator. So here, let me write that out. We take 3 times 6 plus 1, which is 19, and then over the same denominator. All right, let's just do one more to feel good about it. Let's try 2 6/7. So I'm going to take 2 times it by 7 and add 6, which is 20/7. And there you go.